welcome to my channel. And today we are going to discuss about the cat and dog classification. So we can say today we are going to discuss about the image classification using VGG16 fine tuning. So first of all, here I am using Google Colab so that everyone can download that file and can run on their machines without having some problems. So let's get started. So first of all, we need to understand what is VGG16. So VGG16 is you can say a convolutional neural network, a CNN. It's already pre-designed. There is an architecture given for VGG16. Here's architecture for VGG16. So it to take the image of 224 by 224 is the height and width of the image, and the three channels are three demonstrate it accept the colored images. So each channel demonstrate a primary color, red, green and blue. That's why there is a three. If that model would have support black and white images only, then it here you would be 2 instead of 3. So 3 represents 3 primary colors, red, green and blue. So in the VGG16 there are 16 different layers, 16 layers of the neural network. Each layer has its own parameters, and here as you can see, the first layer contain 224 by 224 by 3 size, and the second convolutional layer has the same height and width is same, but the filter are now 64. So and after each pooling layer, the image will be divided in two parts. So you can simply say the size of the image, like height and width, would be decreased and the filters would be increased after every layer in that VGG16 architecture. So in simple words, in the next layer, the height width parameters are 1 1 2, so half of 2 to 4, so 112, and that is doubled, 64, now it's 128. And after that pooling layer, again there are the height and width decreased further and the filters are increased. So without going to depth, without going in details, so you can there are so many papers in the internet available for VGG16 architecture. So if you want to get an idea about the theory, then you can follow those articles or those papers. So we will focus on the coding part here, how to use that VGG16 to classify images. And one thing I also would like to mention, in that VGG16 model is trained on the ImageNet dataset. If you search on Google ImageNet dataset, so its dataset has 1000 classes. So if you see that ImageNet dataset, it has 1000 classes, 1000 different images, you can say categories, 1000 images, and it has over 80,000 images in total. So that VGG16 model is designed on is trained on that particular data set. But in our today's lecture, we are going to discuss on like how to classify cat and dog. We have just two classes in our program, so we will use VGG16, but VGG16 is initially trained on 1000 images. So we would customize that VGG16 model to train on just two classes, which are cat and dog. So first of all, we need to import all the required libraries. So we have Keras. You have to install. The beauty of Google Colab is that you don't have to install Python, you don't have to install TensorFlow. Google Colab is designed for those kind of tasks only. So in simple words, if we say Google Colab, it's a platform as a service, you can say. If you are machine is not that powerful, you can use Google Colab. It will run those programs faster. But if we talk about VGG16 in particular, it is like the weight size is too much. That's why the training process is bit slow. So if you say if you use Google Colab, if you don't have that powerful machine, you can Google Colab to make your training process a bit faster. So that's why that's another reason I'm using Google Colab, because training process is bit faster on the Google Colab. Also it depend on your internet speed, however. So now first of all we need to import all the necessary libraries. So I would not list, I would not say the name of each and every library. You can see over here, I will share that GitHub repositories link in the description box, so you can follow that link if you want that code. So the next thing I would do is the input shape for that particular VGG16 model. So now what we are going to do, what we are using transferring learning method. What is transfer learning? We have that VGG16 is already a model. It is trained on 1000 images, so we will use the same architecture, we will use same layers, same number of layers, and the weights of those layers would be same. So we will use it in our custom classes. So that is called transfer learning. So in simple words, if you want to use a predefined model for your own task, so we use transfer learning. First of all, our for that particular task, my input shape, my images shape should have same, like it accept 2 to 4 by 2 to 4 size images. So I am mentioning that input shape over here, and the channels are input channels are 3, because we are going to use colored images in that task. So for now I will load that model VGG16 input tensor is that thing input shape, and then include top true and weights ImageNet. So include top means we need all the layers. We need that VGG16 has different layers. It has pooling layer, convolutional layer, fully connected layers. So we are using each and every layer of that VGG16 model as of now, and weights are same as ImageNet dataset. So you simply you can write that thing as it is for every classification task if you are going to use VGG16. And then I'm not running that code again, because literally it took 3 hours for me to complete that training thing. So I waited for 3 hours to make that video. So I am not going to run those shells again. So it's already, you can see the output after running that shell. The output would be like this. It is downloading that data, downloading those weights from that link, from storage.google APIs and whatever that link is. So it downloaded these many resources. And then model summary, if we see the summary of that particular model, it's the name of each and every layer. For input layer, the output shape is 2 to 4, 2 to 4, 3, and then first convolutional layer, the size became 64, and then further it is going on as I mentioned earlier. So after the pooling layer, here is pooling layer. So after the pooling, after it goes through pooling layer, the height and width of the image is decreased to half. So 2 to 4 became 112, and the filter would be increased in the, so it depends actually, it's up to you how you want to define those parameters, how many nodes you want in your neural network. But in VGG16 it is like that. All right, so but in the process would be same after pooling layer. So it depend on the padding size. There are different parameters actually. If you want me to make a separate video on the theory, how those neural network work, how feed forward work, how back propagation work, how each and every optimizer and activation function work, you can let me know in the comment section. I'll make the separate video on those theoretical concepts as well. All right, so after that, as you in that summary, you can see the name of the each and every layer, and these three layers are dense layers. These two are dense layer and that's flatten layer. In flatten layer, if you see, if you multiply these three together, the output would be that much. So let's see. Okay, calculator, Google calculator I'm going to use. All right, I will multiply 77512 7. All right, 7 into 7 into 512. So the total number of weights would be 25 25088, and then these are the, you can see the neural network. If you see, I will show you something. It's a playground TensorFlow. If you see the structure of the neural network is, these are the, so that is in, if we, that is a neural network, that it's very simple basic neural network. That is input layer and that's hidden layer and that's the output layer. In the input layer there are two parameters, x1 and x2. In the hidden layer you can make any number of hidden layers you want in a neural network. That particular neural network contain one hidden layer. If you want to add two new, so that's now that a neural network has two hidden layers. So you can add any number of neural network, any number of hidden layers in your network. So that is called the deep neural network. If we see that our neural network in our network, we at the input, their input layer is that one. So if we see that particular dense one, what that means, that flattened layer, that layer has 4096 are deep neural. In that particular neural network we have 16 hidden layers. So if we make in that there are just two hidden layers. If you make this 16, it would be similar to, you can say the architecture would be, the image would be similar to the VGG16, and are in that demonstrate the number of nodes and the number of nodes in a neural network. So 25088, if we see in that particular one there are just 4 neurons. So that is the number of neurons in that particular hidden layer, and that is similar to our neural network. Our neural network has two output classes. That one node would be for cat and other node would be for dog. So our neural network is trained on just two classes, cat and dog. If we input any other, for example, if we put elephant's image in our neural network and we want to ask our neural network what is that, so our neural network would either say cat or dog, because our neural network just know two things, cat and dog. So our that the same thing. Okay, we are going, let's move further to the coding section, not go deep dive into that one. So now we have to customize that model. As I mentioned earlier, the ImageNet dataset has 1000 classes. So we want just two output classes. So in that particular, in the dense layer, Now what we are doing in that case, last layer model dot get last layer, after that is layer's name block 5 pool, block 5 pool is that one. So after that max pooling layer, in our flatten layer, that is the flatten layer, and last layer is that one. Every like okay, max pooling block 5's output would be input for flatten layer, flatten layer's output would be input for fc1, fc1's output would be input for fc2. So each layer's output is their input for the next layer. So here you can see the flatten layer, the last layer is the input in the flatten layer. So in our dense layer, so that the x, we are in every line, in each line we are updating that x variable, so overriding that x variable we can say. And in dense layer, in that fc1 there are 4096 weights, you can say 4096 neurons or nodes, but we want just 128. It's completely up to you, you can try putting another number, you can try like 512 or something else, then you can see, you can observe the output, and you can see whether your model is working good or not. So it's up to you. In that code I am just putting 128 number of nodes in the fc1, and I am using activation function ReLU. So it's you can use ReLU, 10h, it's completed. So now in the playground I will show you how that activation function affects the output. If okay, I am choosing that data, okay, I am choosing that simple data, let's say, okay, I am choosing the circular data, it's completely up to you. And learning rate, like it's up to you, I am defining learning rate 0.1 and activation function 10h for now. And regularization, it's penalty parameter, you can put any one, L1, L2 or none, it's up to you. And what you are going to use, is it classification or regression problem? It's a classification problem. I want to classify those two classes, the blue separate and that orange separate. So let's start the learning process. I am using activation function, that's the number of epochs, there are 100 epochs. Oh, it's already, you can see now the loss is 0.02. I think after the now that loss is 0.02. If I decrease, if I remove that layer, now see, let's see, now it's 0.4, 100 epochs are already done, but now that loss is error. Now that difference you can see in the division as well, now it's decreasing very slowly. So now you can see how hidden layers can improve models working. Now it's already 500 600 epochs, but the loss is still 0.4. Now let's now let's change the activation function. I am using now ReLU and start. By using ReLU activation function, the loss is 0.5, it's not decreasing at all. So it actually depends on the type of data, which data you want to use. So you can see it's already 400, though it's making no difference, the loss is still 0.5. And let's change to the sigmoid activation function. You can check that by decreasing number of nodes, and increasing the number of hidden layer, decreasing the number of hidden layer. So in that particular data set you can see it's already 300 400, the loss is not decreasing, it's 0.5 again. Okay, so now let's see the linear function. For the linear function, loss is again not decreasing, it's still 0.5. So that's how the hidden layer can improve performance. So it's again I will test with the one layer only. hidden layer. Oh, okay. I will use there. I decreased that by mistake. There should be two neuron because there are two classes, two different colored samples. So we need two classes in the output layer and input layer, and that's hidden layer. So the linear, but it's still not making any difference. It's 5. So if we change it to the as we in that we observe tan h is working good, relatively good. So yeah, you can see that 0.05 for that particular data, the tan edge function is great for that particular problem. So it completely depends on type of data and the parameter, the input size and everything. So for that, so the as in by using that Google Playground, you can see how activation function can affect the performance of that particular neural network. You can keep changing the activation function to observe the performance of your model. I am using a ReLU function on the hidden layers and softmax function for the output layer. For if you have just two classes, you can use sigmoid as well. Softmax activation function is most widely used when there are number of classes on the hidden layer. So for that thing I am using softmax again as well. So it's completely up to you. You can keep changing it and observe. Okay, no, I don't want to run that. Okay, all right. So I have already run that cell, but I don't want to run that again because it took again 3-4 hours. But now it says model is not defined, so it's expected because I have not ran those previous cells. So okay, and after that I have customized that model. Instead of 1000 classes, now I want just two classes in the output layer and the model input shape. So I just updated that model. So if you see the model 2's summary, okay, that will not take that much time. I can still run that, but the training cell will take time. I'm not going to run that training one because there are 5 epochs. In 5 epochs it took 3 hours, literally 3 hours. So if you have 10 epochs, it may take like 5-6 hours. So I am not that patient because I wanted to make video as soon as possible. So just I just stick to the 5 epochs. It's completely up to your patience. So if you want a good performance, you can use the n number of epochs. It's up to you. Alright, so after that you can summary. The previous summary was in the output layer. In the output layer, then there was 1000 classes, and in the now we have customized our model. Now we have just 2 classes in our model output layer. Okay, so how this calculated, if you want to see how this thing calculated, if you that's on linear function. So you have to multiply this. So the line equation, if you see, slope into m weight into slope mx in plus b intercept mx plus b, yeah. So it's on linear equation. Okay, let's check whether I'm saying truth or not. If you multiply this with this and plus this mx plus v, so our weight value is that into input, which is 4096. Okay, 4096 plus b by 4096 0. It should be that number 10276454. Yeah, it's same. So again, if you multiply this one into this one plus this one, the output would be that. If you multiply 4096 into 1000 plus 4096, output would be that one. Alright, now let's move further. Now we are freezing some layers. We want uh, because VGG16 is the already trained model, it do really well on the classification tasks. So I don't want to train all the layers again. I don't want to run all the epochs on all the layers again. So to save our time, I just want to run only last three layers which we have customized. So the weights of the previous one, because our input size is same, our input size is 2 to 4, 2 to 4, 3, and the image input size, filter size, all is same. So I just want to use previous layers and previous weights only. I will just train last 4 layers. So I just excluded layer dot trainable false. So a -4 demonstrate the last 4. So before those images means the top 1 images, let's say top 12 images, I don't want to train them. I just want to train the last 4 images, just last 4, which whatever dense fc1, fc2 and output. So if you see, I just set trainable false on them, and if you see over here, it's already for all the top layer 1 2 3 4 5 whatever those are, all are not trainable. So we just want to train these 4 layers flat, and which we have customized for our in according to our data. Okay, so after the compile, in the custom VGG model.compile, I just want to use the categorical cross entropy loss function and optimizer Adam and matrix accuracy. So I will not go into detail. I'll just explain simply what is categorical cross entropy. If we see how our neural network learn, okay, how this learn, how it a particular neural network learn. Firstly, for but one input, it goes to one hidden layer, and each layer the weights are calculated, mx plus v the linear function, and then there is some output, and that output passed to the activation function, and that final output in that particular perceptron, what happens? Firstly, it calculate weight bias mx plus b, then that output passed to a activation function, and then the final output of that particular neuron, that particular perceptron passed to the another layer. So that particular thing, that is called feed forward. And after the feed forward process, the weights and biases calculated to check the error. What is the error, like what the difference between actual output and the error. So according to that output, it back propagates. There are different gradient descent, there are different things we use, like for back propagation, when it back propagates, the weights changed, and then so that one epoch contain feed forward and back propagation. So what is the role of that categorical cross entropy is, it is basically, you can see after the one epoch, it calculate the loss, it calculate the error, and then optimizer Adam optimizer function is used to update the weights. So after first epoch, in simple words I would explain, after one epoch it calculate the error, and then according to that error it change the weights. Basically in the deep learning, in the neural network, it's all about the weights and biases. Once we get the appropriate value for the weight, our model would be good, our training, our neural network will be learned. So after Adam function, optimizer function is used to update the weights. and Adam is a good optimizer. There are different optimizer. There is RMS prop, there is Adam optimizer. So there are different optimizers. So Adam is, I have used Adam. You can use any other. It's completely up to you. And then there is ADA optimizer as well. So basically what it says, Adam is the combination of ADA and um, RMS prop. The matrix accuracy, basically accuracy is simply how it is calculated, the proportion of the actual output and the predicted output, like the what is the final performance of the that model. For example, if out of 100 classes 80 class the model predict 80 classes correctly, 80 images correctly, and then it we will say that the accuracy is 80% of that particular model. And now, so that process, till that we have prepared our model for the training. Now we now we want data, we want our customized data to train our model. So now I am going to, in my laptop I don't have that much space, to be honest. I put my data on the Google Drive. So on the Google Drive, if you want to feed directly from Google Drive to your model, so you don't have to save data locally in your computer. You can just simply use a Google Drive for that. You can to mount the Google Drive, so Google Colab will check data from Google Drive. You have to just use drive.mount function and you will use the same as that content drive. Now I will prepare my data. So where is in my drive there is a folder called cat dog 1000, and in that folder there are subfolder train and valid. I have just created those variables. And training samples, there are 2000 images, and validation sample 800. So out of 2000 image, there like to train I have used 2000, to check to test I have used 800 samples, and epochs 5. Initially when I ran that for the first time, very first time, I used 10 epochs, but it took like 5-6 hours for me. I kept my laptop on overnight, and then it finally completed the training process. So for that I have just used 5 epochs. It's completely up to you. You can use any number of epochs. After that, like after 10th or after 11th epoch, it depend on your size of data, the output remains same. So you can just use like for example, after 10 epoch the output is accuracy is 88%, then after 12th it's 88%, then it's 88%, and after that it's 87, 86. So after some time, and if in the epochs, if we change the weights, then the performance may started decreasing further. So the whenever your output is like same for consecutive or for continuous 2-3 epochs, you can just use same number of epochs, like you don't have to go further. All right, for this I will just use 5 epochs. It's not the best number of epochs. The like 10 is good than 5, but for that particular example I just use that one. Okay, my PC's battery is coming. I will just put my charger on. Alright, so batch size is 16. So batch size is in the epoch, like how many samples you want to run in each batch. Like in that one I have 16 samples in one batch. So then train data generator. In that image data generator function is used to transform the images. For example, if I say the example of MNIST dataset, I will take the handwritten digits dataset example. For example, if there are images like one is, we will say one is like that. If we train our model, if we train our neural network, that is one. If the image is like that, for example 1000 times 1000 for 1000 samples, one is like that. So our model learned that one is just like that. So if the image is like that, it will not recognize. So there should have a variation in our data set. Similarly, if our model learned 2 is like that, if the 2 image is slightly like that, it will not recognize our model. So what we have to do is we have to create some changes in our data set, because the real world data may have some distortions, may have some changes, variations. So to make those variations in our data set, we use image data generator. I have just rescaled there. I have used feature extraction. I want those pixel value from 0 to 1. I have just divided that to the 255, because 255 is the maximum pixel value. So now the images features would be from between 0 to 1. Rotation range, so that's how we rotate our image. For example, I gave that example. If you want to rotate like 90 degree, then our some images would be like that. So that's rotation range. For that cat dog, if the image is, for example, the cat is for example like that, for 20% it just rotated a bit to prepare that for future data. Width shift range and height shift, it just changed its height and width. Horizontal flip to, some of images may have flipped horizontally. For example, okay, for 2 it may be like that, horizontal flip. If there is vertical flip, how it would be? It would be like that. So that's complete the view how there are different parameters for image data generator. You can play around. Okay, I have to run that. Okay, in our Jupyter notebook usually we do shift tab to see the parameter. Okay, image data generator has different parameters you can use according to you. And then validation data generator, for validation, for just testing, we don't want to change the validation data, we just use the feature scaling. We don't want to rotate, change horizontal flip or something on validation data, because anyhow we just use that data for testing purpose, not training purpose. For training, we just ensure that our model trains on variety of data. And finally there is a training process. For the training process, I have created two variables, train data generator and validation data generator. I have used that directory that I have created earlier, train and validated, train data directory and validated. I fed that directory to the model, and the target size, target height and width of our data. Batch size is how many number of samples we want in one batch, and class mode we want categorical. And then validation, same as we have our same variable, and then move to the fit generator. So that's where the actual training process starts. Here the feed forward and the back propagation going on, and in each epoch there are optimizer change the weights of those parameters and so on. So in simple words, we are just making our neural network learn, that is cat, that is dog, to think, to learn the patterns of the data. In the each if we say like in each and every hidden layer, what a model do, it learn the different edges, the different parts of the image. All right, so then after that, it looks simple, like there are just 5 epochs, but it took like 5 hours for that to run. Not like for 5 epochs, so it's 2.5 or 3 hours, and for 10 epochs there was 5-6 hours. Yes. So after first epoch, you can see loss is 0. 0.4 and accuracy was 80%, and the training testing accuracy was 85%. And after, because sounds, it maybe sounds unfair to you, like how the training accuracy is 80%, how the testing could be 85%, how a model can be perform better in testing. That's because in the training there are more number of sample than the testing. And that after the second epoch, because anyhow it how it calculate accuracy, the actual number of like the correct prediction divided by true prediction, or sorry, how it would be predicted label divided by actual labels on it. And in the second epoch there was 125 steps per epoch. Okay, and then 80 accuracy 86 and the testing 89. And after third epoch accuracy, so you can see after every epoch, after each and every epoch, accuracy is increasing. After the optimizer is doing good, we can say it is changing weights to the more relative weights. So after the now the accuracy from 80% in first epoch, after the fifth epoch it's now 90%. If you run those further, the model will perform even more better. Now how we can save that model? If you want to save that model and you want to use that model further, you can use that model in every application. You can use that model in your web application, in your desktop application, even you can use it as a API as well. So I have just saved that model to the h5 file, cat.finetune.h5. That model, that file can be used in any application now. Okay, now how to load that save, we can run those files because we have already that file. New model. Okay, what it says, it says no file or directly found. Okay, cat dog classification, how I can save. Okay, where it saved it. Okay, it wants permission as well. Whenever you mount your Google Drive to the Google Colab, it asks for permission, so you have to allow it. So it's for your safety purpose. I feed email as well that my Google Drive is being accessed. Alright. Model.file. Okay, I will look into that where it is saved. Chaos associate. Can you know you are saving the model history? So the format is configured. Okay, so that's a warning. Okay, I can use dir function to check how the directories in that particular location. I don't want to do this as of now for the, because I do not edit my video. I just don't do blurs and those stuff. I just upload it as it is. Okay, so just we can just simply see the output. So for that cv2 numpy.pandas matplotlib, and it has, okay, base dir. I have to run that shell as well. Base dir. I have to check the location of that model, or whether it is saved permanent. It was saved permanently, or it was. I just need to check. Or temporarily, it was temporarily saved or permanently. I have to go through that one. Okay, so now I have a test image. I used OpenCV to read that image from our cat dog 1000 test and cat dog with .jpeg. It's on my Google Drive. That is in the testing folder there is an image called cat.jpeg. So testing data shape is 355 to 7 and 3. But now the problem is because we have trained our model on the 224 224. So we want input sample as 224 224. That's why we use resize function. OpenCV resize to resize that testing sample. So we have resized to 224 and 224. Now if you see that image, it's that one. So it's very cute cat. PLT matplotlib matplotlib libraries PLT function I have used for that. PLT.im, so it's that image in our testing data. And if you see, I have used that 255. It was integer data. I changed it to the float and then reshaped it to, because our training data in our training, how the array size was, how the arrays you can say shape was. It was according to the number of samples. For example, if like there was, if there are 1000 images, it was like that 1000 and each image was 224 224 3. But now we have to change that our testing sample same as that. So that's why I have reshaped our array to make it that dimensional 1 2 2 4 2 2 4 and 3. So for 0 classes refers to the cat and 1 class refers to the dog. As you can see in our in machine learning, it works on the numerical data only. It do not know what is cat, what is dog. It label it as 1 0 or 1 0 class is used for cat, because cat folder was first in, so it is according to the serial wise. Cat was the first folder in my folder, so that's why it labeled it to 0, and dog is the next folder, so it labeled it as 1. If there is any other thing, like for example there is elephant, then it would be class 2 and so on. And the classes, so now we want to predict that label. So now that is the testing time. That is the crucial time. Let's check our model, how our model is performing. Our model is performing good or not. So model dot predict test. Our we loaded, that's our test variable. We override that variable and we have changed its type to float and reshaped it, and now we are just feeding that test data to our model. So our model was saved to the new model variable. There you can see over here, new model. That was the new model. New model, load model. We have loaded that model, and then if you see, that a new model dot predict the test, and then okay, now one more thing, why that argmax is used, I will let you know. For example, how the prediction array would be, how the output of that output layer would be. For example, there are 10 classes in the output layer. There are 10 neurons. I will use that one. All right. In the output layer, there are, what happened to the paint, or whatever. So in the output layer, for example, there are three classes. So we have three classes. Let's say we have three. One is for cat, other is for dog, and third is for elephant. Let's say the output layer's output would be like that: 0.8. Alright, 0. For example, let's say it's 0.7. That is 0.7. That is 0.1, and that is 0.2. So it's probabilities, and that is for cat, that is for dog, and that is for elephant. So now that is 0.7, 0.1, 0.2 in our neural network. When we feeded the one image in our neural network, for example, that's the image. We want our neural network to tell what is that image, whether it is cat, whether it is dog, whether it is elephant. So our neural network thinks there are 70% chances, there is 70% probability that it is a cat. There is 1% probability that it's a dog. There is 0.2%, like there is 20% probability that it is an elephant. So the array would be like that. The probability array would be like that: 0.7, 0.1, and 0.2. Now alright, so now we want argmax. What argmax do? Argmax calculate the argument, the maximum argument, the index of the maximum argument. That is 7. Here if we apply argmax function, then it will return 0. So the argument like 0.7 is the maximum out of 0.7, 0.1, 0.2. 0.7 is maximum, and what is the index? Index is 0. So the index 0's value is maximum. So that's how it works. That's how argmax works. So it will say that our testing that image, that particular image is for cat, because level 0 is for cat, level 1 is for dog, and 2 is for elephant, let's say. And now let's move further. It predict. So if I have labeled it like that: 0 label is for cat. For classes of 0, what is that? Cat. So that's how it predicts. As you can see, as I have already explained that how it argmax function works. The probability is like that: 9 point something for label 0 and 7 point something for label 1. So that's why it says that the given image is for cat. Model dot predict. So it's 0.9, 90%. So it's 90% sure that the given image is cat's image. So now I wish if that model, I am not sure where I have stored that model in our Google. I will let me find that model. So okay, I will make, because I don't actually edit the videos. That's all for now. I will just look for that x5 file. So in the next video probably I will show you the more customization. I will feed more images, and the model will work good. So trust me guys, it is the best. VGG16 works best for these kind of tasks. So that's how you can now use that your saved model x5 file to the different you can use it in the video as well to recognize cats and dogs. So there are different, for example, if there is you can check the occurrence of cats and dogs in that particular video as well. So there are different projects you can use in VGG16. Alright, so that's all for that video. Thank you so much. If you like that video, please subscribe my channel for the further videos. I'm going to upload various videos on deep learning concepts if you could. Thank you and have a good day.